Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz. I just want to say thank you for joining us, and I hope you find the information useful and that you can apply it in your applications and your needs. And so today we're going to be looking at how to ensure that screws are tightened in the correct fastening sequence. And so with this always comes around the same subject of error proofing when we talk about sequence control. And error proofing is being able to get things done right the first time, helping us to be able to prevent mistakes during the fastening process. If there are mistakes, that we can go ahead and manage those and take care of them right away. And finally, this all encompasses the philosophy around poke yoke, which the person who is actually credited for this type of error proofing system, Shinzo Senja, said that defects only happen when they're allowed to reach the customer. And so if we can help to prevent those types of errors, especially when it comes to sequencing, and making sure that everything is done correctly, then we can rest that we can have that error proofing process within our fastening sequence. And so some of the problems that we face during a sequence and tightening failure, that could certainly come about if we are dealing with any type of gasket type of situation where you may have one side of the gasket lifted and one side tightened a little bit more, so you could get some, again, some lift. We want to make sure that the actual gasket itself is fully seated, and we want to make sure that all of the fasteners that need to be fastened are fastened within that process. And we can also look at the idea of when it relates to flanges, or if it relates to electronic components where they need to actually fit into their application correctly. And again, for safety critical type of applications, the sequencing can be very, very detrimental and can cause catastrophic failure if they are not done correctly. If you look at when you have your wheels on your automobile put on, the lug nuts should be tightened in a pattern to help prevent any type of additional stress on the lug bolts or on the nuts within that assembly. And so if you have that type of situation, we can see that failure happen. Now that's going to lead us to our poll question for today. And that is going to be, do you have an application that requires fasteners tightened in a specific sequence? And so it's a simple yes or no question today. And so with that, I'll give you just a few seconds here to go ahead and answer that question. I'll go ahead and get a drink. All right, so our poll started off with a number of yeses straight out of the gate, and then some of the no's caught up at the end. But the predominant answer was that yes, people do have the need for sequence control, and so hence you are watching and listening to this presentation. And so some of the common mistakes and challenges that we see in normal manufacturing are going to be lifted fasteners, fasteners that are completely under torqued. You may also see fasteners that are over torqued. dealing with the operator and how they do their specific application compared to another operator. So there are a number of different challenges that face the actual assembly process that we can try and help to mitigate and help to eliminate some of those outside influences by implementing some error proofing types of controls. And so, how can we safeguard against sequence and tightening failures? First, if we use equipment that does have error proofing capabilities, this is giving us the ability to track each screw within each screw that the tools need to fasten. We can monitor and track the progress that's happening throughout the assembly process. We can also, again, help to eliminate the operator influence, which is a majority of the errors that we may see within the assembly process, ensuring that every screw is tightened correctly and in the correct sequence. And if we have the ability to detect an error when it does happen, then we can go ahead and take care of that before it moves down the line or eventually may reach the customer or end user. And so the human error risk that we might see would be an operator that misunderstands the actual necessary sequence process. And so you may have an operator that feels that they know what is the right way to do it, and so they are not necessarily following the procedure. They may have a lack of experience or training, and they're using the wrong parts, or again, not following the right procedure. The experience level or the actual operator with their ability to just simply pay attention to what they may be doing and may inadvertently cause an error as they aren't necessarily following or actually are in the moment while they're doing their assembly. They may be thinking about other things. And then looking at the lack of supervision or oversight that may contribute to all of the human errors that you may see. And so when we talk about a way that we can ensure the sequence process, we can look at a position control system. And this basically is a all-in-one position control torque arm system that has a couple different components with it, but it does give us the ability not only to track what's happening, but it gives us the ability to make sure that the operator finishes a particular step within the process before they can move on to go ahead and continue through the application. So it actually guides the operator through the assembly and not allowing them to make a mistake. And so with the position control system that we offer, in this case, and for the demonstration that we'll be looking at, we'll be using our articulated arm. And this arm has basically two encoders where we're monitoring where the tool is in space. And we have one encoder that monitors the articulated portion of the arm, and another encoder at the top that monitors the amount of rotation the entire arm uses. And we can define what is an acceptable area for the tool to have power in a given location. So we can control when the tool has power based on the location of a particular fastening within the assembly process. Now there are a number of different types of arms that we also offer. We have a linear style arm that has two encoders on it. This arm goes up and down, it goes in and out, and it can go around the access point. And then we also have telescoping arms as well. And these are really good because we can control the tool power and the location a couple different ways. And so we have one telescoping arm that can monitor the length of the arm. So as the arm is extended to a specific location, we can monitor what that distance is. If we need to go another step, we can monitor the length, and then we can also monitor the amount of angle that the arm is at. And then if we need to go even further than that, we can monitor the angle, we can monitor the rotation of the tool, and also the length. So we can get very sophisticated with the type of tool that we may be using. And so we have different arms that allow for different scenarios and different applications to be able to help control during the assembly process the actual location and position of the tool. Now, the actual benefits of using a position control system in an arm is going to give you an additional benefit as it relates to ergonomics. This is going to help provide protection to the operator, especially as you get up into maybe some higher torque values where that tool is now set in an arm, and any type of additional inertia that may be generated when that tool does shut off is completely absorbed by the arm itself. It also allows for 100% transfer of the torque that the tool is delivering to the part, and we're not losing any in the operator once that tool shuts off. It's going to also help to prevent any type of repetitive motion injury or any type of carpal tunnel type of scenarios. So there are some additional benefits to using a position control system with a torque arm because we are then eliminating any type of shock or reaction to the operator. And typically the tool is always suspended by a balancer. So the tool then becomes a weightless type of operation. So the operator just simply needs to move the tool into the correct location and then do the rundown of that. So there are a number of different benefits to using the system. Now with ours control system, it also works in conjunction with our Posi Touch display. Now this display not only helps to do the programming for a specific application, but it also allows us to have work instructions for the operator to follow to let them know at which point in the operation that they are at. This really helps to reduce the need for a PLC. Each unit has 12 digital inputs and outputs, so we can use this system with line control devices. We can also use it with monitoring systems, light trees, pneumatic locks, and we can incorporate all of the IOs that may be needed to help control the assembly directly from the Posi Touch controller. It's Industry 4.0 ready, and again, it's going to help us ensure the sequence that we want to use it for. Now, there are a number of different tools that we can use with this. We can use a standard clutch transformer style of tool. We can use a pneumatic style of tool with this. It does measure the torque that is, or the signal for a good rundown differently than it would be in the scenario that we're using it in today. And that is with a DC tool, our ECTD product. And so in this case, we are connected to a DC control tool, and the tool will let the touch know that we received a good rundown, and then the system will go ahead and index to the next step within the process. The sequence-based fastening is really important. Again, we kind of touched on it a little bit, but we do a sequence for a specific reason. Whether that reason is to make sure that every fastener is done correctly and our board or our part is seated correctly, or it may be a way that we need to build our component through using subcomponents. We need to work in a certain pattern. But this is really kind of the essence of sequence-based fastening. Now, the actual position control will allow us to be able to do screw counting within a specific step that we are using. The Posi Touch system almost is a job manager. So if you do have kind of a low mix, high volume, or either a high mix, low volume scenario, we can have more jobs than you may need within a specific use of one particular Posi Touch and arm system. And it makes it very easy to be able to create and use within the system. It does have the ability to be able to set this up in one type of scenario at one station. If you have multiple stations, you can then take that information and then just copy it over to other ones. So once you create a scenario or a job, you can go ahead and back that up or save it and then deploy it in other places. And then there may be some location updating for that, but it does allow us for that easy sequence creation. So that is going to lead us to our demonstration for today. Again, I'm using our DC control tool with our articulated arm and our DPC touch. And so here is the thread block that we have. We also have the touch and the controller. And so the display is basically telling us what we need to do. And so when I go ahead and I press the button, it's going to give us our work instructions here. So we are going to tighten these 6 fasteners within the thread block. Now I've not completely done this program, so we can go ahead and finish the programming of it, but right now you're seeing a non-graphical image of where we need to be. You can see the current location of the encoders. If I move the arm, you will see that the tool is now in a locked position. When I move the tool to the correct location, it will then be okay, but you can see that our current status is red within our assembly. So let's go ahead and jump into how we actually will do the rest of the programming here. So I select it, we can hit edit, and then you can see our program recipe right now. And then our fastening is what we want to edit. And so I have 6 locations saved right now, and you can see the data for each one of those. And I've also used the location for that. But let's go ahead and add the image of the thread block. And now once we use this in the actual sequence process, it's going to let us move through the process and highlight which fastener we need to use. So on all 6 of these fasteners, we're using preset number 1 on the controller. And this is basically would be a pre-torque type of step with that. For our final pass, we're going to use 2 different presets. But with the system here, since we already have the location data, I can simply copy the fastening step. And now we can go in and we can edit which presets we want to use. And so again, we have our image, we have our locations saved here, and now we just need to update the tightening job or preset that we want to use. And so for fastener 1, we'll use preset 2 for our tightening. And also, if there's an error, we would set our retightening job. Now, you do have the ability to let the operator attempt the retightening of a fastener that may have erred from 0 to 9 times. And so you have that ability to control how many times you want that retightening job to be. And then so for these last fasteners, we're going to actually use preset number 3. And this is automatically going to select that preset based off of the location for that number of the fasteners. So all we have to do is save this. We can save the entire job, and then we just simply load it. And now we just follow the instructions on the display. So go ahead and press our button. It's going to give us our work instructions. And now we have our location target. And once the tool is in the correct location, you can see that there is power to the tool now. We can go ahead and run this fastening. If we get a good fastening, it'll go ahead and index. If I move outside of the fastening area, then it's going to lock the system up. But now we've got a good rundown for each of the locations. And if the tool, again, is not at the right fastener, we don't have power. And again, this is all using preset number 1. Now we're going for our second pass, and you can see that the tool has automatically changed to preset 2. And we are torquing this to 2.25 Newton meters. And if we hit an error, then the system is now going to allow us to go ahead and retighten using the same preset. We get a good signal. It now indexes to our 4th fastener, which is now a preset change and a torque change to 2 Newton meters. And we've now finished our cycle, and we go ahead and we can begin that process again. Now, we could also use a barcode scanner as well to be able to select a specific job. So if a part came in again in that high mix, low volume type of situation, we could use a barcode scanner to go ahead and select that and pull up that specific job. So if we're other ways that can be a specific job can be pulled up. It could also be used if you are using a PLC or other input devices that we can use to help manage all of the different scenarios that you might have during your assembly process. And so with that, that's going to complete our presentation for today. Let's go ahead and move into our questions and answers section. And so, Chris, do we have any questions?
Morning, Dave. Yeah, we have a couple of questions to start. Besides an electric screwdriver, can this system be used with a pneumatic tool?
It can be used with a pneumatic tool that is ported, meaning that it has the ability to monitor the airflow of the tool, of the air tool. And so in this scenario, we are measuring the amount of time it would take to run down a specific fastener at a specific location. And then we monitor how or when the tool is on and when the tool is off. And we monitor that in milliseconds. And if that fastener falls within whatever window we deem acceptable, it will go ahead and count that and index to the next fastener. So yes, it can be used with a pneumatic tool. as long as that pneumatic tool is a ported style of tool. It can work with a standard electric clutch transformer tool or with the DC tool.
All right, thanks, Dave. Next question was, how many images can be uploaded for the job manager on an application?
So the number of images are, let's see, we can have up to 99 different images within one particular job. And within each job or within each fastening, within that image, we can have up to 99 fastenings for that one specific image for that particular scenario. If you need more than that, there's other ways that we can link different jobs together by using some input signals to be able to use more of those if you needed that more than 99 for that particular space. Correct. I
All right.
may actually be wrong. It might be 256 different images. So we can double check that.
Okay. The next question was, can the device be connected to a PLC system for line control management?
Yes, there are digital inputs and outputs. There are 12 of those. We can hook that up to a PLC for line control. The PLC can also select which particular job we might want to use. It can receive a signal once the job is complete. And so there is that ability to communicate back and forth with a PLC.
All right, Dave. That looks like that's all the questions we have.
All right. I want to thank you very much for joining us today. And we look forward to seeing you with our next webinar next month. And with that, have a good day. And thanks very much for joining us.